getting ready to start Chapter 3, studying quadratics. But before we do that, we're going to go through some review of quadratic ideas that you started to learn in Algebra 1, and we're going to build from there. So remembering those simple elementary skills that you learned, like factor trees, we're going to be utilizing those ideas. Now first, when you started in Algebra 1, you learned a concept that was called foiling. We said that word a lot, foil, where the FOIL stood for finding the firsts, the outers, the inners, and lasts. But why did we do that? Why did we FOIL? So when we had to multiply two binomials together, for an example, 2x plus 3 and x minus 1, when you're multiplying two terms together that each have two terms, you have to distribute in some sort of system. So we came up with the word FOIL to represent which terms to do in which order so that we remember to multiply all of the terms together. So we would multiply the first terms in both binomials together. That would give us 2x squared. Then we would do the outer terms. 2x times negative 1 gave us a negative 2x. We would do the inner terms, which would give me positive 3x, and then we would do the last terms, which would give me a negative 3. Now, if I break down what this multiplication of two binomials gives me, it gives me 2x squared minus 2x plus 3x minus 3. But we can go back and simplify and collect our like terms, which becomes those outer and inner numbers. Those are our like terms. So when we simplify this, we end up with 2x squared plus 1x minus 3. Now in algebra, all things come full circle. So when you learn towards the end of algebra how to factor, what we were doing was we started here with our product and we had to break down what our factors are that gave us that product. So what we're going to be working on for a couple days is how to break this product down and get us back to where we started with. So that is, some people will say unfoiling. That is considered factoring when we work backwards. So again, you'll have to utilize all those skills you learned in elementary school when we talk about factoring and breaking down a number. So we're going to be looking at different cases today. Now, the first technique I want you to always remember, no matter what the problem is you always want to look for the GCF first. So when I look at this, I see two terms, and I want to see if there's anything collectively I can pull out of both terms. So I notice that a 4 and an 8 have a common factor of 4. And I notice that a squared and a have a common factor of a. So I'm going to pull out of each one of those or divide out a 4a. That's my greatest common factor. So I'll pull out a 4a and that will give me 1a plus 2. Now when I look and analyze what I have, there's no other ways that I can break down a plus 2. So I am going to say that this is factored completely. 4a times the quantity of a plus 2. Now what's nice about factoring is I can always go back and redistribute and make sure that I get what I started with. 4a squared plus 8a, so that checks. And I do have the factors. All right, so that's one with two terms. Let's look at one with three terms. So the three terms tends to get a little tricky because what we have to do is kind of analyze how did we get that outer and inners to make that middle term. That's what's going to be the tricky part. So when I break this down, I look for the GCF out of all three terms. I notice that the only GCF I have of all three terms is 1, so I have nothing to pull out to begin with. Now I'm looking at how do I break this down? So simply recalling that when my last sign is a plus, that means my two signs in my binomials are going to be the same. In this case, they're both going to be pluses because the second sign is a plus. So these are some techniques that you learn. We're just reviewing these techniques. Now, I'm going to break down the x squared. So there's only one way x squared factors, so that's going to be nice and simple when I put those in, x and x. Now with 6, I have a little bit more work to do because 6 is going to factor into 1 and 6 or into 2 and 3. What I'm looking for are those two factors that add, because this is the same, together to get 5. And that's going to have to be the 2 and the 3. So I get an x plus 2 and an x plus 3 when I factor that down. Now I always check before I move on. So my firsts give me the x squared. My lasts give me 6. I know I'm good on that. What I always stop and think about is can I still get that middle term of 5x? So I look at my outers. That gives me 3x. I look at my inners, that gives me 2x, and if I add those together, I get a positive 5x. So my two factors remaining are x plus 2 and x plus 3, and I can check that off. All right, moving on to our next example, I have x squared minus 8x plus 12. So again, the first thing I'm going to do is I'm going to look for that GCF and see if I have one. So I look at every term and see if they have anything in common. All three have to have it to be able to pull out. And I notice my GCF is 1, so I have nothing to pull out. Now I'm going to analyze my signs. Since this is a plus, that means my two signs have to be the same, and that also means that I'm going to have to add those terms to get my middle term. So when I go to break this down, I know that they have to be the same, and because this is a minus, they're both going to be negatives. So I have my problem set up. Now I'm going to look at my factors. So I'm going to factor that x squared. Again, there's only one way that factors. That makes it nice and simple. But 12, I have options. So 12, I have 4 and 3. I have 2 and 6. I have 1 and 12. I need to get myself to have a negative 8. So I think that's going to work best with that 2 and 6. That'll give me x minus 2, x minus 6, and I'm going to check my outers and inners. So when I work through my problem, my firsts work, my lasts work. Let's make sure my outers gives me negative 6x, my inners give me negative 2x. That's going to total a negative 8x, and that works. So my factors become x minus 2 and x minus 6 when I factor that quadratic equation. All right, on to our next example. Again, the first thing I'm going to do is I'm going to look for my GCF, which with all three terms, my GCF is still only 1. This time, my last sign is a minus. That means that my two signs have to be different, and that also means that I'm going to have to subtract my two factors to get my middle term. All right, so I'm going to break this down. Again, I know that I have to have one of each because of that negative sign. I'm going to do the easy one first. Let's do that x. We know that's going to break down to be x and x. But 15, I have a little bit of work to do here. I know my factors could be 1 and 15. They can be 3 and 5. But I'm looking for where I subtract to get the number 14. And I believe that's going to be the 1 and the 5. Since I have to have a positive 14, I'm going to make my larger factor be positive? Now again, I'm going to check that just to make sure. My outers give me a negative 1x. My inners give me a positive 15x. When I add those together, that gives me 14x. So we are good to go. My factors are x plus 15 and x minus 1. All right, so now let's look at a equation, or not an equation, an expression that we call a slip and slide. So notice that for the first time, I'm having a coefficient in front of my quadratic term. That makes things a little bit more challenging when I go to factor. So I'm going to show you a technique that's called a slip and slide. Now, first of all, just like always, I'm going to look for my GCF and pull that out if I can. So if I look at all three terms, I only have one in common, so I have nothing to pull out. Now, how do I use slip and slide? So what I'm going to do is I'm going to take this 6 and I'm going to multiply it to my last term and make that a negative 18. Now, I can't just change my equation like that. I'm going to slip it over, or slide it over to the other side, but I'm going to have to bring it back at the end of my problem. So now what I have is an expression, x squared plus 7x minus 18, that I need to factor. All right, so I notice same thing as before. When I have a minus here, then I'm going to have one of each sign. And I notice that my first term is x squared. So I'm going to start by factoring that x squared into x and x. Now I'm going to work on that 18. Since that is a negative 18, I know once again I'm going to have to subtract my terms to get that middle term of 7x. So I'm going to do my factors. I have 18 and 1, I have 9 and 2, I have 6 and 3. Now if I'm going to have to subtract, that means that my two factors are going to have to be 9 and 2, with the larger factor being the 9. So I'm going to go ahead and place that in there. Now here's the problem. If I check this, I know that I'm not going to get what I got at the beginning, because 9 times negative 2 is not negative 3. But you remember that we slid that 6 to the other term. Now we've got to take it back out of there. So what I'm going to do is I'm going to divide that last term, each of them, by that 6 I took out at the beginning. All right, now, if you have a reducible fraction, reduce it to its simplest form. So this would be x plus 3 halves, and this would be x minus 1/3. Now what you're going to do is slide that denominator to the front of each binomial. So that's going to make this be a 2x plus 3. And that's going to make my second binomial be 3x minus 1. Now I'm going to go ahead and do my check. So my firsts give me 6x squared. My lasts give me negative 3. I'm going to test the outsides and the insides, and that gives me 7x. So this is indeed my two binomials, 2x plus 3 and 3x minus 1. Now that's a special technique you can use. You don't have to do those problems that way. You can surely factor that 6x squared into 3x and 2x, or 6x and 1x, and play with those numbers. But if that technique helps, please go ahead and use that. All right, let's look at some special cases that we have. This is a special case, and we're going to see why in the end. So you can see I'm going to check for the GCF first. My GCF is just 1, so I don't have anything to pull out. Now you notice that I have that slip and slide situation, so if it is easier for you to take that forward to the other side and not worry about it till the end, do that now. So that would make me have an x squared plus 20x plus 100. Now, since this is a plus, I know that both factors have to add together. Now, if I factor my 100, I can get a 10 and a 10. I can get a 2. I have a lot of factors, 25 and 4, but I think 10 and 10 is going to do it because I need to add those two terms. So I'm going to go ahead and place those two factors in here. Now, not forgetting that I got rid of that 4 at the beginning, now I have to add it back in. So I'm going to divide both by that 4, just the second terms. Then I reduce 5 halves. And now I'm going to slide it back over. I'm going to take that 2 back in front in both terms. So that gives me a 2x plus 5 and a 2x plus 5. Now if I test, I get 4x squared, I get 25. Now I test my outers and inners. My outers are going to give me 10x. My inners give me 10x, and I know that that's going to give me 20x. So my solution here, or my factors, are 2x plus 5 and 2x plus 5. Now I called and said originally that this was a special case. Now this is a special case because both factors are exactly the same. That means that this was a perfect square trinomial. Now you should remember this from Algebra 1, but a perfect square trinomial factors into the same factor so that you can write it as a perfect square. So how do I recognize a perfect square trinomial at the beginning? Well, I notice right away that I start to see some perfect squares in there. So when I see those perfect squares, I need to make sure that my middle term will work with my outers and inners. So I pay attention to the 2x factors and then the factors of the 25 so that those outers and inners give me 20. Now, if you didn't recognize that at first, that's okay. You can simply use that slip and slide method. But whenever our factors become exactly the same, that is a perfect square trinomial. All right, so we have one more special case. Now this is a special case where I only have two terms. I do not have a GCF. Now I could have a GCF, but I don't. Now when I only have two terms, there's only some special cases that will factor. And what this special case is a difference of two perfect squares. Now, you'll hear me reference this. I'll say, oh, that's a DOS. That's short for difference of squares. How a DOS works is when you factor a DOS, you're always going to have one plus and one minus because of that minus 4. The x squared is going to factor into x, and then 4 becomes the square root. 2 and 2. Now why it ends up being just two terms is when I'm checking this, my first term gives me x squared, my last term gives me -4, but my outers and inners, watch what happens to my outers and inners. Because they are one of each, 2x and -2x, that always cancels and I lose my center term. That's what happens with a difference of squares or a DOS. So you please be aware. Now notice that if this were x squared plus 4, it would not factor the same way. We might think that we could factor x plus 2 and x plus 2, but that doesn't give me center terms that will cancel. That will give me a 4x. So actually x squared plus 4 is prime, that means it doesn't factor. So this special case with perfect squares only works if it is a minus with perfect squares. We have some other special cases like difference of cubes and sum of cubes that we'll learn later in the year. But for our quadratics, it's just when it's two terms, the only way it will factor is if it's the difference of two perfect squares. Okay, so I hope that you understood this review. On Google Classroom, you will find this factoring polynomials worksheet that I'm going to go over with you in a few minutes. So check on Google Classroom for some extra practice.